let's initialize the centroids probabilistically. So uh, now I will explain how this probabilistically means. So first, initialization of centroids C1 to Ck in K-means plus plus. So here d equal to xi and there are no yi's here. That is why it is called unsupervised learning, and there are n data points. So let me first read the steps, then I will explain uh, with this image. So what it is doing is first pick the first centroid randomly from the dataset, which is called C1. And if you recall, in K-means, at first step only the number of, suppose there are three clusters, then in first step only three clusters will be chosen, and after that number of iterations will be take place, and then the number of, then the clusters will be taken. But here in K-means plus plus, first you pick the first centroid C1, and then for each points xi in dataset D, create a distribution as follows. So what it will do is, for each data point xi, it will calculate a distance square which is between xi and the nearest centroid. Nearest centroid means for first iteration it will be distance between xi and c1, because in first step the nearest centroid is c1. So like that, for whole data set x1 up to xn, it will calculate the distances d1 up to dn, and then it will pick a point from the dataset which is d minus c1, because c1 is already chosen as centroid, and which is proportional to di. So what does it mean? So if di is high for any xi, then chance of getting chosen as next centroid is high. So for example, uh, it is this is for k-means, and this is for k-means plus plus, and let's say number of data points are 200 and k equal to 5. So in k-means plus plus, suppose the whole data sets are scattered like that, and first you will take this point as the first centroid. After that, from each data points, like uh, uh, from this centroid, it will compute the distance between the others. Suppose from here it will calculate the distance for these points, for these points, and for these points, and it will take the distance which is maximum as next centroid. So you can see that from that centroid, this is at the maximum distance, so it will take this cluster as the next centroid, and then this and then this, like that. But here in k-means plus plus, in first iteration it will choose some centroids, and then then the centroids will change. So actually now let's see the loss function. So here the loss function is, for each clusters and n data points, this loss function will be minimized, and in words it is saying the intra cluster distance. So intra cluster distance means, suppose this is a centroid, and intra cluster distance means within this cluster it will compute the distance between this centroid in and these points, and it will try to minimize it. So what it will do is, it will assign this xi's to the nearest centroid, so this loss function will be minimized. So this is the loss function for k-means plus plus. And if you see what is the why k-means plus plus is better, so you can see from this picture that for these two clusters, actually, which in this case these two clusters can be one cluster, because the cluster is very small, and it is unnecessarily creating two clusters instead of one. So you can see in k-means plus plus that these two clusters are merged in a single cluster. And for this cluster in k-means, so you can see that this cluster is very large, so it is intuitive to make it into two different clusters. So you can see in k-means plus plus that whole cluster is divided into two cluster. So that is the main advantage in KMeans plus plus. So I think now these steps are clear. So first you pick the first centroid as C1, then for each point in xi in dataset D, create a distribution like you have to calculate the distance square from xy to the nearest C1, and you will pick the maximum distance as the next centroid. Like that it will take place. So conclusion, in K-means more than one centroids may be introduced into a similar group, bringing about poor clustering. But K-means plus plus prevents it by initializing the centroids probabilistically. So that is the advantage of using K-means plus plus. So now the question is how to choose good K for both K-means plus plus and K-means. So first option is, um, if you have domain knowledge. Suppose you want to, um, if you want to um, cluster different reviews of food reviews or sentiment, different um, um, reviews. So in food reviews, if there are two, uh, one is positive and one is negative, so it is intuitive that k equal to 2 will be the best. This is the first option. And if you don't know the how many clusters will be taken, then the method which is already discussed, so it is elbow method or knee method. So for that, if you plot this in x-axis, this is the squared loss, and in y-axis the number of clusters, and you will see the for which k the loss is minimized, and you will take the this k as the best. So one might ask that why not use cross validation to choose best k like KNN. So if you recall, in KNN what we have done is, so we have used cross validation data to get the best k. But here in this clustering algorithm, you don't have any yi's. That is why it is called unsupervised. So you have only xi's. That is why you can't do it. Can't use cross validation to choose best k. So you have to use this method, elbow method or knee method, or you have to use your domain knowledge in which problem you want to use. So in KMeans plus plus is already implemented in scikit-learn. So in scikit-learn, there is a function is called KMeans, and there are several parameters, and all parameters are not mandatory, but these four are important, I think. So first one is n clusters, and next one is init. It is mean initialization. So initialization, it can take two things. One is k-means plus plus and another is random. So if you want to use k-means, then you just write init equal to random, or if you want to use k-means plus plus, you write init equal to k-means plus plus. Or if you don't write anything, by default it will take k-means plus plus. So that is the second. And third and fourth is, if and that is n initialization. So by default it is 10, and it is saying that number of time K-means algorithm will be run with different centroid seeds. And there is, and fourth one is maximum iteration. So it is the maximum number of iterations of the K-means algorithm for a single run. So here the most important arguments are these two. First one is init and second one is n clusters. So now here the problem is, so here I want to classify three types of flowers, which is called, one is Iris setosa, Iris versicolor, and Iris virginica, using K-means plus plus, and to choose what is the best K. So I think it is intuitive from this problem statement that there are three types of clusters. So K equal to 3 will be the best choice. So now let's see how to prove it using K-means plus plus. So and here to cluster it, there are four features. One is sepal length, sepal width, petal length, and petal width. So you can see from this picture that this is called sepal and this is called petal. So this is called sepal length, sepal width, and this is petal length and petal width. So these four features are given to you, and you have to cluster uh, three types of iris flowers. So first of all, you have to import the K-means library, which is from scikit-learn.cluster import K-means, and then loading the iris dataset, which is iris.csv, and if you print it first 10 rows, you will see that there is an id, sepal length in centimeter, sepal width in centimeter, petal length and petal width, and species. So id setosa, virginica and versicolor, like that. So first of all, you have to take these four features because id is useless. So to take this, you have to use this df is the data frame, and I location is integer location. So integer means first, second, third, fourth column. So it is 0 1 2 3 4. These four columns are needed. So and you store it in x. If you print it, you will see that this is the sepal length, sepal width, petal length and petal width. And next, if you just run k-means for k equal to 5 randomly, so you can do that. So as I have discussed that init equal to random means k-means and n clusters equal to 5, and then you just and this model is initialized, and then you just run fit predict. So it will create the several clusters, and if you print it, you will see that there are 5 clusters, 0 1 2 3 4, and this is the cluster centers. Centers means actually this is a four, and in this data set there are four features. So this is um, four dimensional space. So this is you can think w x y z axis, four axis here, and this is for sepal length, sepal width, petal length and petal width. And as I have created 5 clusters, so each clusters are denoted by 1 point. So this is for the first cluster, and this is for second, and like that for this is for the fifth. And if you plot it, to plot it you can use the scatter function, the x-axis, y-axis. So I can't plot four dimensional in this case, so I have just used 2D plotting, scatter plotting. And then I have used this c equal to y underscore k means 5, which is the 5 clusters, and the color is rainbow. So you can see that the 5 clusters are not so well, and one cluster is overlapped with other. So that is why k equal to 5 bit not the best choice. So you can also run k-means plus plus for k equal to 5. So the code will be same. You just change this init equal to k-means plus plus, and rest are the same. And you also see that the clusters are overlapped to each other. And then you have to plot to find the best case both for k-means or k-means plus plus. You have to plot this elbow method or knee method. So in x-axis there is a error loss, and this is squared loss. And in uh, sorry, x-axis is k and y-axis is error loss, error or loss. So I have run this for 1 to 11, k equal to 1 to 11 I have used. So I have here used k means plus plus. So k means equal to k means. So if you want to find for k means, then you will just write init equal to random, and rest will be the same. So you can see from this picture that I think k equal to 3 or 4, the loss is minimum. So I have, and now you just fit k-means using k equal to 3. So I have used k-means, then init equal to random here, n clusters equal to 3, and then I have plotted the cluster 0 1 2, and then this is the cluster coordinates, 4-dimensional coordinates, and you have plotted it. So you can see that um, for 3 I think this is better than the 5, and also I have plotted for 4. So now I am coming to k-means plus plus using 4. So if I want to use k-means plus plus, you just write init equal to k-means plus plus and n clusters equal to 4. So you will get the cluster 0 1 2 3 and the cluster coordinates. And if you plot it, you will see that here also the points or clusters are overlapped to each other. Red are overlapped with this violet, uh, and then for k means plus plus with k equal to 3, n clusters equal to 3, you will see that this cluster I think reasonable. um, Although there are some points are overlapped, but you can see that here is a cluster, that is the cluster, and this is the cluster. So in conclusion you can say that k equal to 3 is the best case for iris data set, and using KMeans plus plus. So that's it.
Thank you.
Yes.
Any question?